Okay, for our momentum and impulse problems, we don't really have a lot of equations, but we're going to have to reason through a lot of different things. So I'm going to go through the equations, go through the variables and the units, then we're going to solve two problems. And I'll make a separate video for the second problem so the video is not too long. Momentum is nothing other than the product of mass and velocity, right? So mass times velocity gives you momentum. Because of this, momentum, just like velocity, has a direction. So you can have two different momentums in opposite directions, right, that add to zero. Because one is headed one way, the other is headed the other way. They can add to zero, or they can add to something else. So momentum is the product of mass times velocity. Because it's a product of mass times velocity, the units are kilogram for mass and meters per second for velocity. And just as, the units for mass are kilograms, units for velocity are meters per second. So mass times velocity gives us kilograms meters per second. If you pay attention to units a lot, then there are a lot of things you can learn just from the units. The reason we talk about momentum and the reason we emphasize momentum in physics a lot is because momentum is conserved. So if a collision happens, I've got two objects with momentum P1 and P2 before the collision, and then after the collision, after they've run into each other and whatever has happened, they now have momentums to P1 prime and P2 prime. Then momentum conservation means that the sum of the momentum before the collision equals the sum of the momentum after the collision. This is a key concept in physics, that momentum is conserved, because momentum is conserved in situations in which kinetic energy is not conserved, something we'll talk about later in the semester. All right, so here we have momentum of object 1, momentum of object 2, they collide. After the fact, momentum of object 1 plus momentum of object 2 equals the momentum from before the collision. Another expression you're here and connected to momentum is impulse. Impulse represents a change in the momentum of an object. All right, change in momentum. This is why the Star Trek engines are called the impulse engines, for moving around in the solar system and things like that. These engines change the momentum of the ship. The equation for impulse is J is the impulse, J equals delta P, right? That delta means change in momentum. And it's usually, we often write it P final minus P initial. So it's your final momentum minus your initial momentum. If we look back up at the conservation of momentum equation and we try and write J1 for particle 1, object 1, and J2 for object 2, J1 is delta P1 is P1 prime, its final momentum, minus P1, its momentum before the collision. And the same for P2, J2 is P2 prime minus P2. All right. All right. So we're going to skip over problem 1. You guys got that one in the bag at this point. Problem 2. All right. Problem 2. I'm hoping that you get that one without any problem. We're going to head all the way down to problem 4. Problem 4. All right. I'm going to just grab all of this, pop it over to Word. Okay. We have a car headed north. It has a mass of 1480 kilograms at a velocity of 24 meters per second. We have a car headed south with a mass of 1149 kilograms and a velocity of 11 meters per second. They collide and stick together. What is the impulse for the car headed south? Now, the reason I wanted to do this one is because it actually involves several parts. So let's think about this. We have the car headed, let's start with the car headed north, right? It has this mass and this velocity. Not a great drawer with the mouse. It has that mass and that velocity headed north. And then we have another car headed south. It has this mass and I've covered it up a little bit, but that velocity. All right? So they collide and stick together. All right, so let's play with the consequences of that before we get into the numbers. They collide and stick together. What does that mean? All right, so I've got momentum 1, which is m1 v1, right? That's my 1480 kilograms times 24 meters per second. Now the other one is headed in the other direction, so that means I have to subtract it because it's headed in the opposite direction, m2 v2. Now they collide, and now we have some new velocity. All right, I've rewritten momentum as m times v, right? And since I don't know what the new velocity is, I'm not going to put a sign on it yet, right? v2 prime. So there we go. All right, but what else do we know? They collide and stick together. What does that mean? What does it mean they stick together? Well, you know, in terms of the math, what it means is they have the same velocity after the fact. Right? These velocities have to be equal. Why? They're stuck together. So they have to be moving at the same velocity. And I'm just going to call this, for simplicity, I'm just going to call it v prime. All right? So now the equation up here, I can modify a little bit. That's not v1, that's v prime. All right? And that's not v2 prime, that's v prime. All right? Which means I can go a little further and just do m1 v1 minus m2 v2 equals m1 plus m2 v prime. Now, v prime. Now you can see from this, right? Because they're stuck together, they're acting like one object, aren't they? They're acting like one object, m1 plus m2. They are stuck together, they're one thing, they have one velocity. All right, so let's figure out what we need. Let me back up a little bit. What we need, we're asked for, is the impulse of the car headed south, right? J is going to be the change in momentum for the car headed south, which is car 2, right? So that's going to be m2, and north is our reference direction, right? So m2 v2 prime minus, all right, if north of our reference direction, we've got a minus, so we end up with plus m2 v2. All right, so that's where we started out at. This is what we're after. We're after the impulse, right? Impulse, J is delta P2, all right, the car headed south. This is, it's a momentum after the fact, right? This is minus its momentum before the fact, right? Minus the minus m2 v2. We now know that v2 prime is just v1, so we can rewrite the impulse. J is m2 v prime plus m2 v2, right? So we're down to, if we know v prime, we know the impulse we're after. Well, if we look at this equation, the only thing we don't know in that equation is v prime. So let's solve for v prime. V prime, do that again, v prime v prime is m1 v1 minus m2 v2 all divided by m1 plus m2. All right? That's v prime. Now we're after the impulse, right? So let's stick it in. J equals m2 onto all of this I'm just going to go up here. I can do a copy and paste. You guys have to go the long way around, right? Minus, plus M2, 2, the other 2, the one that looks like that, V2. All right. Now we know the impulse on car number 2. Everybody good with that? Right? Okay. And that's it for this problem, which was what, problem 4, I think. One of the harder problems. I thought I would do that. And we'll do the next problem in just a minute. All right. Good luck with this one.